I'd like to tell you about a car I'm restoring and show you the actual reassembly of the engine in a kind of time-lapse sequence. I hope some of you watching find this as interesting as I do, but I know there are others who won't find any redeeming value to this and will be bored to tears. You should go find something else to do before it comes to that. I feel compelled to justify spending so much time on this. Some people feel that keeping a car is a burdensome, if not evil, necessity. Others disdain cars as material possessions unworthy of our attentions, even as symbols of our materialistic obsession. Well, I could go on and on about the beauty hidden in the details of a car, the dichotomy of complexity versus simplicity, the yin and yang. But I'm going to let it go with the simple justification that I like it. It's only rock and roll. So let's move on to the subject, a 1967 Porsche 911S. First, I'll tell you about the car itself. Second, I'll describe the engine and some of the more interesting details. Finally, we will watch the engine assemble itself with the help of time-lapse video animation. 67 was the first model year of the 911S. The 911 itself began production in 1965, so this was the third model year for the 911, but the first of the 911S, which was the maxed out high performance model. So the main feature that's unique or different for the S model was the more powerful engine, along with several other details that were intended to complement the additional power. There are better brakes, lighter wheels, rear anti-roll bar, and more complete instrumentation. The power increase was accomplished mainly with better breathing. Larger valves, larger ports, carburetors, modified valve timing, tuned equal length 3-to-1 exhaust headers, and higher compression. The power went up from 130 brake horsepower to 160 brake horsepower. That was a DIN rating, and that 160 DIN is approximately equivalent to 180 brake horsepower or SAE. The maximum power is at 6,600 RPM with a maximum engine speed of 7,300 RPM. So it's a fairly high-speed engine. And it's fairly small. This is a 2-liter engine, or approximately 120 square
Cubic
inches in displacement. I don't have solid confirmation on the number of 67 911Ss built, but I've been told that there were less than 1,000. The factory's engine numbering indicates an allocation of 2,178 numbers, so it must be less than that amount in any case. Also, for the 1968 model year, there were several modifications from the 67 911S, and fewer were built since they were not imported into the United States due to 68 being the first year of federal emissions laws, and Porsche hadn't modified the S engine adequately to comply with those emissions laws. When the 911S was again brought to the United States in 1969, it had undergone more substantial changes than the 67 to 68 model change, both in the engine and the rest of the chassis. Almost every year of the past 20 has continued this trend of the 911 towards bigger and heavier and more comfortable. Although the modern 911s are fantastic cars, which are more advanced and capable than the 1967 911S in every way, many people still think of the 67S as the epitome of the lean and mean production sports car in this long history of the 911 Porsche. Let's move over to the engine itself and start to get a feel for what it is we're dealing with here. There are a couple of features, general features about the 911 engine that I should mention first, and then we'll look at some of the details. The engine is a flat six-cylinder engine. Flat meaning that the cylinders are horizontal, and there are two banks of 3 cylinders each that are horizontally opposed. So rather than an upright or slanted arrangement of cylinders, they lie horizontally, and there are two banks that are opposite each other that go back and forth. We can see that by taking a look at this half of the crankcase. This is the position that the crankcase sits in the car, this being the front of the car, this is the rear of the car back here, and the cylinders bolt in to these holes in the crankcase here. So you can see, in fact, they are horizontal, and the pistons move in and out in those cylinders. The engine's also an air-cooled engine, which means that there is no water as a cooling medium in the engine. There are no sleeves or jackets around the cylinders or the heads, and the cylinders, as you can see by this one right here, are very simple, and they get all of their cooling from these cooling fins that are cast into the cylinder. Likewise, the heads are strictly air-cooled. There's an individual head for each of the cylinders, and it's a very simple assembly. No water or oil passages going through it. Simply fins cast into it to dissipate the heat in the air that is forced over the heads and the cylinders with a fan. In addition to being air-cooled, the engine is cooled quite a bit by the oil, and so there is a lot of the heat is taken out of the engine through the oil and is dissipated into the air with an oil cooler, a fairly large radiator that the oil is pumped through under pressure. Actually installs right here in the engine. And this is a so-called dry sump engine also. There is not an oil pan at the bottom of the engine that all of the oil accumulates in. Rather, there's a scavenging pump that pumps all of the engine oil that collects at the bottom of the sump, and pumps that out to an external tank. And there are close to 10 quarts of oil in the engine, as opposed to 5 for a normal engine. Let's look at the bottom end of the engine. That's the crankcase, the crankshaft, and the connecting rods. We're looking at the crankcase here. It is an aluminum alloy cast case, and magnesium case was adopted in 1969, which was 22 pounds lighter and required considerably less machining time during manufacture, but is not quite as strong or rigid as the earlier aluminum casting. And in fact, a few later engines that had very high output special application engines returned to use this aluminum case for the additional strength. The design of the case and the crankshaft is inherently very strong and rigid. You can see by the just the supporting webs for the main bearings in the crankcase here, you can see that almost a third of the length of the crankshaft is supported by bearings. It is a full 6-bearing design for the 6-cylinder engine, so that means there's a main bearing on each side of each of the throws of the crankshaft. The bearings are conventional plain bearings, both for the mains and for the big ends of the connecting rods, the connecting rod bearings. The crankshaft is forged for additional strength and uniformity, and it's, as you can see, it's a fully counterbalanced design, and it is a fairly complex design. It's a 3-plane design crankshaft also, to provide a better natural balance for the flat, horizontally opposed 6-cylinder engine. It is I guess I did mention it's a forged piece rather than a simple casting. The connecting rods are fairly conventional. They're all also forged. And for the 67S, they also adapted a soft nitrided finish processing to strengthen the rods even further. One unusual thing about the connecting rods is that the design of the bolts used to tie the two halves of the big end together around the bearing was a design that stretched the bolt when the correct amount of torque was put on the fastener. The bolts were actually stretched, and that put a certain amount of spring tension on that fastener, and so that was the only mechanism used to lock the nuts onto the bolts. There was no other locking mechanism used, and it also has the effect of ruining the bolts every time you tighten them up to correct torque. So every time rods are installed in this engine, you need to use new bolts and new nuts. Let's move on to the top end now, and maybe we'll zoom in a little bit so you can see some of the details of these parts a little bit better. At the top end, of course, we've got the pistons, the heads, the valves, the camshafts, carburetors, headers, etc. The pistons are possibly one of the more beautiful pieces in this engine. They're a very tall hemispherical design. You can see the pockets cut in the crown of the piston for the valves. It's a light alloy material, and it also is forged as opposed to being a simple casting. You can see that the design is a box cross section that for increased strength and also reduced friction area. There, the contact area of the skirt is just on the two sides. A large amount of the skirt by merit of this box design is cut away, and there's no friction there with the cylinder wall. The compression ratio for the S engine was increased to 9.8 to 1 from 9.0 to 1 for the... The heads, again, are a very simple design. There's an individual head for each of the cylinders, each of the combustion chambers. Again, due to the fact that it's air-cooled, there's no water jacket involved here, there are no oil passages involved here. The small amount of lubrication that is needed for the valve stems is fed external to the head. There's simply the combustion chamber here, the intake and exhaust valves, the intake and exhaust ports, the valve springs back here, and the hole for the spark plug. Because of the hemispherical design, there's a space on the other side for a second spark plug that is used in some applications. The valves were increased in size. Both valves, each valve was increased 3 millimeters in diameter in going to the S engine. The intake valve is 42 millimeters, the exhaust is 38 millimeters. Likewise, the diameter of the ports were increased, and the earlier engines, the normal engines, they were each 32 millimeters in diameter. They were increased to 35 millimeters for the intake port and 33 millimeters for the exhaust port on the S engine. The valve train is of an overhead camshaft design with a single camshaft over each of the two banks of heads, and the camshafts are driven from the crankshaft with chains. The camshafts were changed, the valve timing was changed in the S engine, primarily to provide more overlap of the opening of the valves. The intake valves are opened a full 20 degrees earlier than in the earlier normal engine, and the exhaust valves are opened 2 degrees earlier than the normal engine. The carburetors are the 3-barrel Weber carburetors that very similar to the ones that were used in the year prior to 67. There are 2 of these 3-barrel carburetors, so each of the cylinders has its own barrel. There were 2 changes in going to the S engine for the carburetors. The venturis, the effective diameter of the carburetor barrel, was enlarged by 2 millimeters to 32 millimeters, and there is a minor difference in an auxiliary fuel jet in this S carburetor as compared to the earlier normal carburetors. And finally, coming out the end to the exhaust headers, Porsche came up with a completely new design, a tuned header system, equal length pipes of using three exhaust pipes on each side, tuned equal length into one to take advantage of the scavenging effect possible. And finally, probably the single one item that added the most power to this engine was the change in the shroud that goes on top of the engine. This is the air ducting that's used to channel the air from the fan. It sits on the engine like this. It ducts the air from the fan down through the cooling fins on the cylinders and the heads. And for the S model, they changed to a red color, which is has been used on all of the top performance models in the 911 engines since then.